Hello 108 students, Mr. McHugh back here with you. We are going to go ahead and on this video take care of 2.5 section again, continue our work on page 2. And what I wanted to do up here real quick, I just told you that if you ever multiply or divide by a negative number when you're dealing with an inequality, less than, greater than, equal signs, you need to switch the sign. Why is it? Why must you memorize this rule? So I'm going to offer you an informal proof here. I'm going to take the statement 6 is less than 12, which is a true statement. Now, I'm going to multiply both sides by a positive 2. Allowed to do that. I'm maintaining balance on the equation, so multiplicative property of equality allows you to do that. And I get the statement now, 2 times 6 is 12, 12 times 2 is 24, and is 12 less than 24? Is that a true statement? Yes. Okay, so when you multiply by a positive number on both sides of the equation, what do? You leave it alone. Awesome. Why must you switch it? Because it's a negative. Take the same inequality, 6 is less than 12. Now multiply by a negative 2 on both sides. Okay, what do we get? Negative 2 times 6 is a negative 12. 12 times negative 2 is a negative 24. Okay, now, if we leave the inequality alone, we are saying negative 12 is less than negative 24. Is this a true statement? Well, let's just do a proof here real quick. Here's 0. Let's find negative 12, and let's find negative 24. Okay, what are we saying here? Is negative 12 less than negative 24? Okay, that answer is what, class? False, right? Everything to the right is bigger. Which bigger? Which side is bigger? Between negative 12 and negative 24, the negative 12 is bigger, not less than. So therefore, that is wrong. With that said, here's where you must switch the inequality sign and say negative 12 is what? Greater than, because it's on the right-hand side of the number line of negative 24. Okay, so that's all the proof you really need to know, that whenever you multiply or divide by a negative sign, you switch the inequality sign. Now, in class, I like to talk about a little story, kind of date myself here again, but there was a movie on TV back in the 60s called Lost in Space, and there was a robot on this movie who was to protect the boy, and whenever there was danger, his arms would flap up here. If I was going to draw I'm not very good at drawing robots, but he was a big bulky robot, hands out here, and he would flap these hands up and down, say, warning, warning, danger, Will Robinson, danger. And I try to get this in your head now, the danger, danger. Whenever you multiply or divide by a negative number, what must you do, class? Always, always, always flip the inequality sign. So think of that big robot waving his arms over, danger. Multiply or divide by a negative number, switch the sign. Okay, so a couple examples here. 5x less than or equal to, there's an equal sign in there, negative 30, isolate the x. Remember, keep practicing what you're doing. You ice the inequality sign, divides left side, right side, isolate the variable, divide by 5 on both sides. You have x is less than or equal to negative 6. Did I need to flip the inequality sign? The answer is what? No, because I divided by what? Positive. Okay, and you could see all of the graphing stuff there. I'm not going to do that this time. Now look at 3b. Here's an example. Negative 4x less than or equal to 32. You're finally working a problem out. You come down to this statement, and now you know you need to divide by negative 4 because you got to isolate the x variable. And so you divide by negative 4. You must do it on both sides. And as soon as I come over here and say negative 4, dividing by warning, warning, danger, right up here, first thing I need to do is flip the inequality sign. Make it a greater than or equal to sign. X greater than or equal to negative 8. Okay, that's the big concept we're learning here in this section. All your algebra tools you've used for isolating the x variable apply here. You can look at example 4. See the problem. Greater than or equal to 7 minus x, and what catches your eyes first? Hopefully you see the parentheses and you remember the distributive property. You got multiplication, so 3 times x is negative 3x, negative 3 times 4, negative 12, plus 2, greater than or equal to 7 minus x. Okay, I see negative 12 plus 2 is 10, and then I looked at the negative 3x and the negative x. I added x to both sides, and when I did that, here's the 7. I got my negative 2x minus 10 is greater than or equal to 7. Okay, another step, got to isolate the x term, so I add 10 to both sides, so now I've got negative 2x greater than or equal to 17. 7 plus 10, 17. Here's the big moment. You're dividing by what? Negative 2. So warning right there, warning, divide by negative 2 on both sides. Now, when you do that, negative 2 divided by negative 2 is a positive 1. I switched the sign from greater than to less than, and then I took a positive divided by a negative and wrote my answer as negative 8.5. Okay, it's always the coefficient in front of the variable, the last step, the closer step. If you ever have to divide by a negative number, then you're going to flip or switch the inequality signs. Okay, do not get sucked into whether this is a negative or positive of any other numbers. You're looking and ask yourself, whenever you multiply or divide by a negative number, flip the inequality sign. Okay, so that takes care of that objective here. We've got number 3 here, objective 3, and when you first look at these equations, they will drive you a little batty because all of a sudden this is a 3-part inequality, and you'll notice the variable is always in the middle. It's negative 3x minus 1 is in the middle, and the left side has got negative 2 less than or equal to the middle, and then you've got the middle part less than or equal to 5. Okay, now they tell you to solve for this. The easiest way to do this is to realize the x is always going to be in the middle, and what do you got to do to isolate that x term? Now, it doesn't matter doesn't matter what side you cover up, just to get you going. Cover up one side or the other if it helps, and ask yourself, what do I got to do to isolate this negative 3x? I see this minus 1, and the opposite of minus 1 is plus 1. So you do it on all 3 sides: middle side, right side, left side. So maintaining balance now is a 3-sided triangle. Think of that. You're gonna, whatever you do, you're gonna plus 1 to all 3 sides. Thus, if you're going to make that triangle bigger, it'll be equally big on all sides. Okay, negative 2 plus 1 is negative 1, less than or equal to negative 3. Notice the 0 here, less than or equal to 6. Okay, now you're down to the closer step. What do you got to do to isolate the x? Turn around and take the coefficient, which is the negative 3, and divide all 3 parts, the left side, middle, and the right side, by negative 3. When you do that, what's your results? Now, negative 1 divided by negative 3 is a positive 1/3. Here's your x. Here's 6 divided by 3 is negative 2. But wait a second, what happened? We divided by what, class? Negative. Therefore, we should do warning, warning. What I do with the inequality signs. Less than becomes greater than. Less than becomes greater than. Okay. Now, when you have that, when you have to switch it by that, you'll notice here, rewrite the order of the line. You want to do now is read this and ask yourself, this says x is less than or equal to 1/3, which I wrote over here this way. And now over here this says x is greater than or equal to negative 2, and I wrote it over here. So you switch the sides and the inequality signs when you do that. So when you graph these, you always need to have a less than or equal to with the x, and that's going to produce the graphs that in this case, here's 0, here's negative 2, here's 1, here's 1/3, and you're going to go less than or equal to between them, so you're going to put the brackets on those points and you're going to cover in between. Okay, Mr. Q, that's it for page 2. I will see you on page 3 to wrap this up. Okay, bye.